Section 7.3, Graphing Linear Inequalities. In Section 2.5, we graphed inequalities with one variable on a number line. In this section, we will extend our work with graphing by graphing linear inequalities. I think you will find that there is not a huge difference between graphing linear inequalities or the linear equations that we have been working with in previous sections. Let's consider the inequality 2x plus y is less than or equal to 4. Notice that if the less than or equal sign was changed to an equal sign, the inequality would change to an equation and would be 2x plus y equals 4, which is a standard form equation. So we are going to start by just graphing it as an equation. So if you are given 2x plus y is equal to 4, I am just going to go through and set up a table of values x and y. And I'm going to let x equal 0. If x is equal to 0, that means y would have to be equal to 4. Then I'm going to let y equal to 0. If y is equal to 0, that means that x would have to be equal to 2. So if I wanted to graph this particular equation, 2x plus y equals 4, I know that I need to put points at 0, 4 and at 2, 0. So now I am just going to go through and graph this equation, 2x plus y is equal to 4. I'm going to put a dot at 0, 4. I'm going to put a dot at 2, 0. And then I'm going to go through and I am going to draw my line showing that particular equation. So if I go through and draw my line for that, let me go through and do that on here. The line looks like this, and then I can go through and put arrows at either end, and that would be what the equation is. But I'm not doing an equation, I am graphing an inequality. So now I need to figure out, well, what points on this particular Cartesian coordinate system are going to be points that satisfy the inequality that I have. And there's a very easy way of figuring that out. I'm going to pick any point that's on either side of this particular line that I've drawn. I'm going to just try the point 0, 0. That will be an easy one. If I have the inequality 2x plus y is less than or equal to 4 and put 0 in for x and 0 in for y, I would get 0 plus 0 is less than 4. And that is a true statement. So I know that this particular point works. If one particular point works on this side of this line that I just drew, that tells me that all the points are going to work on that side. So in order to do that, all I'm going to do is I am going to shade in this entire side, because any point that is on this side of the line would satisfy this particular inequality, including, of course, because this is equal to 4, including any of the points that are on that particular line. Now, let's just check that by taking a point that's on the other side of that line. So I will just try this point 3, 2. If x is equal to 3 this time, and y is equal to 2, 2 times 3 gives me 6, 6 plus 2 gives me 8, and 8 is not less than or equal to 4. So that shows that that point does not work. If that point doesn't work, none of the points on that side are going to work. Oftentimes people call this kind of the line that I drew the boundary line separating the points that do work and the points that don't work. Here's another example of an inequality to graph. Y is greater than 2x plus 3. Notice This particular one, if I rewrite it as an equation, y equals 2x plus 3, this is written in slope-intercept form. So I'm going to use the idea of slope-intercept in order to go through and graph this particular equation, first of all. So if I want to go through and graph this particular equation, I know that the y-intercept is 3. So I'm going to put a dot at 0, 3. I know the slope is a positive 2, which means I have to go up 2 over 1. So if I go up 2 over 1, I could put a dot at the point 1, 5. Or if I go down 2 and over 1 to the left, I can put a dot at negative 1, positive 1. I can continue if I want to and put in more dots if I want to, if I wanted to draw this particular equation, draw a line for this particular equation. But once again, now notice that this is an inequality that I'm actually doing. So I'm going to go through and I'm going to do the same thing. I am going to go through and I'm going to draw my line for this. But one very important thing when I draw this particular line, because this equation, this inequality I should say, is greater than but not equal to, I don't want it to include any of the points on the line. So now when I draw it, it's going to be a dashed line. And maybe I'm not going through all the points perfectly, but you certainly get the idea. So now my line looks something like that. But because once again this is not equal to, I have a dashed line. The dashed line indicates that it does not include the points on the line. Now I just have to determine what side of the boundary line are the points that satisfy this particular inequality. And once again, my inequality, y is greater than 2x plus 3. You'll notice that when I do this, I usually, first of all, try the point 0, 0. The reason I do that is because 0, 0 is pretty easy to put into the inequality and see if it works or not. So if y is equal to 0, is 0 greater than 2 times 0 plus 3? Well, 2 times 0 is 0 plus 3, so is 0 greater than 3? No, it's not. So that means that the boundary line of this, all the points to the right of the boundary line, don't work for this particular inequality. And I am going to verify that I didn't make any mistake by choosing a point on the other side. So let me, once again, I'm going to go through and choose a point. I'll choose the point negative 3, positive 4. So I'm going to put the points negative 3 in for x and 4 in for y and see if this works. Is 4 greater than 2 times negative 3 plus 3? Let's see, 2 times negative 3 is negative 6. Negative 6 plus 3 gives me a negative 3. Is 4 greater than negative 3? Yes, it is. So that tells me that everything on this side of that dashed line is a solution for this particular inequality. Here's one more example. Y is less than or equal to negative 4. If I were to write this inequality as an equation, I would just have y is equal to a negative 4. And remember from previous discussions, if y is equal to negative 4, I just know y always has to be negative 4. I don't care what x is. So I could say x is 0. I could say x is 1. I could say x is negative 1. I could plot these particular points if I wanted to as I go through. Here's the point 0, negative 4. Here's the point 1, negative 4. Here's the point negative 1, negative 4. And if I were to draw a line for this, and once again, now notice I want to draw this inequality, and it's less than or equal to, so this line is going to be a solid line. It would be going through this particular way. Now I just need to figure out, well, what points satisfy this. So I'm going to pick a point. for this particular one, I want y to be less than -4. So if y is less than -4, that means all the points that are smaller than -4, which would be all of these points down here. So any points in here would satisfy this particular inequality. As I mentioned at the beginning of this section, graphing linear inequalities is not a lot different than graphing linear equations. The one area to be careful with is remembering when the line is a dashed line and when the line is a solid line. Please make sure you ask if you have any questions. Thank you.